So good morning, everyone. I'm very excited to be here today to deliver what is actually one of my last planned talks at a conference that I don't organize. So next year, I'm actually not planning to submit to any Scala conferences. I'll still do a couple hand invites when it makes sense, but I'm going to take some time to focus on building software and building a new company. And that makes this talk, as my last sort of scheduled talk, the perfect opportunity to discuss my maybe controversial opinions about the Scala community. Insert wicked laugh here. I'm going to be talking about snake oils and elixirs in the Scala language, Scala ecosystem, Scala libraries. And in order to do that, I wanted to talk just a little bit about where the term snake oil came from. So the word snake oil comes from America, but the history of that term goes all the way back to China. You see, in China, they had these water snakes, lots of water snakes. They're actually a kind of mildly venomous mud snake. And they would take them and they would slit them open and put them in pots, and they would boil them. And all the fat would bubble to the top. And then they would scoop up this fat and they would turn it into a medicinal oil. And then they would actually give it to people who had arthritis. And it turns out this is actually a sane thing to do, because snake oil, as it turns out, when it's made from Chinese water snakes, contains a huge amount of omega-3s. Chinese medicine was way ahead of its time. And then in the gold rush in America, so the 1800s, was when tons of immigrants came over from China and helped operate some of the mining operations. And that's where snake oil was first introduced to America. Now, some people chose to make their fame off of mining and finding gold in America. Others, however, chose to make their money off of scamming other people out of their money. And one such person was a cowboy known as the Rattlesnake King by the name of Clark Stanley. And Clark Stanley, he caught wind of this magical oil from China, this snake oil from China, and he decided he wanted to get in on that. So what he did is he came up with an alternative to water snake oil, because there are no Chinese water snakes in America, rattlesnakes mostly. He came up with a rattlesnake oil. Only he started claiming that rattlesnake oil could cure anything in the world. So liver disease, gout, rheumatoid arthritis, didn't matter, but there were a few problems. First off, not only did he make these outrageous claims about snake oil, but he wasn't using Chinese water snakes. He was claiming to be using rattlesnakes. But in fact, there were 0 rattlesnake in his potion. It was all made from beef fat. Beef fat. And he would have these elaborate shows out in public, and he would pay certain members of the audience at the right time to stand up and say, hey, this worked for me. And he would scam huge numbers of people out of their money. And hence he came to be known as snake oil salesman. That's the origin of the term snake oil in America. Now, technology, I don't really think we have any snake oils per se, unless it's aware being sold by a commercial company. Then take everything you hear with a grain of salt. But what we do have, I think, in all programming languages are technologies that are maybe a little overhyped. You know, we're hoping to get this much out of them, but in the end, they don't quite live up to that. That doesn't mean the technologies aren't useful. They can be quite useful. We can get a lot from them. We can use them to build great software. But at the end of the day, in many cases, they don't quite live up to the hype. So when I say snake oil in this presentation, I am referring to that kind of snake oil. Not the Clark Stanley kind per se, but the kind of technology that maybe doesn't live up to our expectations. And when I say elixir, on the other hand, I mean something that is going to live up to its expectation, or maybe already has in some cases. In Elixir, I'll be using that terminology just to denote something that, yeah, this is probably everything we thought it was going to be, or even more. Does that make sense? Well, let's go through a few examples. UML. Does anyone remember this? We were going to draw diagrams, fancy diagrams of our software, and we were going to push a button and generate all the code. How did that work out? Snake oil? Snake oil, yeah. How about types, static types? Python laughed long and hard about our static types, and now in Python 3 you can actually do static type checking. In fact, with Facebook's Flow, you can static type check JavaScript. How's that? Snake oil or Elixir? Elixir, of course. How about object-oriented programming? You can't get them all right. Snake oil. Because a 3 million line of code object-oriented code base is not necessarily any better than a 3 million line of code C code base. They're both terrible in different ways. Git. There was so much hype around Git when it came up. Finally, a version control system designed by someone who knew what they were doing, designed for working distributedly. And I looked at that and I noted the horrible UX, user experience that is Git, just really awful. And I thought, no, that's never going anywhere. Well, it took over the world. Now everyone uses Git. SOAP. This was going to change our lives too. This was going to be the protocol to end all protocols. We would forever interact with remote systems using XML and client libraries that were generated from yet more XML. Didn't work out so well. Generics. Remember when generics were introduced to Java? And some people were like, no, we don't need this. This is extra complexity. Now, no one is brave enough to introduce a language without generics, except Google. And we won't speak much of Go. Insult to programmers everywhere. How about null? C doesn't even have null. Doesn't have null. I mean, you can have a pointer that points to 0, but nothing special about that. Null was added. And of course, it's been called the $1 billion mistake. Probably $1 trillion at this point, actually. Definitely snake oil. JavaScript, on the other hand. Here's a language that was designed in a week under pressure and time constraint. A language without lexical scoping. Does anyone know that run into that problem before? No lexical scoping in JavaScript. And it's a language that can't even decide if 1 is equal to 1. And yet it literally took over the world. It is the #1 programming language in the world. Exceeded anyone's wildest expectations. Your phone runs JavaScript. Probably your watch runs JavaScript. JavaScript is frickin' everywhere. ORM. Snake oil or Elixir? Yeah, for sure. People thought objects, we got objects over here and we need persistence. Let's build an ORM to deal with it. Like, created more problems. Definitely snake oil. So you got this. So we're gonna walk through now, step at a time. This is my framework for evaluating tooling and language features and libraries and even functional programming. Kind of like the ThoughtWorks radar, technology radar. Only hopefully a little less boring. We're going to walk through these areas one at a time. You ready? And sometimes, once in a while, I'm going to ask you to help me. Because I'm not going to render a verdict, snake oil or Elixir. That's up to you. So you got to help me out here this morning. Tooling. Is it just me, or does it seem that every few weeks, maybe every couple months, we get a new Scala build tool? I can't count how many build tools we have now. It seems like there's more coming up all the time. We of course have Fury, and we have Mill, and Seed, and CBT, and lots more besides that. And the reason why we have all these different build tools is back to SBT. Stands for simple build tool. I like to think of it as standing for standard build tool. I think that's closer to the truth. Honestly, I don't have anything against SBT. I like it. I use it. It gets the job done. Personally, build tools are the kind of thing I set up one time, and then I try to get as far away from that, stay far away from that as humanly possible. I never want to touch that again. But SBT has been causing people quite a bit of pain for some time. And some people cite the slow compilation speeds, very slow compilation speeds, which have been improved recently. Others cite the rather weird language in which you define your build file. It's not really Scala, unrestricted Scala, per se. And it's not really data. It's not a declarative specification of build. So really, it doesn't have the benefits of a full-fledged programming language, but it also doesn't have the benefits of a declarative build specification. It's this weird hybrid. What is this language here? Scala 3? That joke's for the 4 of you who see the colon equals operator there. You got it. I have to remember that the jokes are delayed 2 seconds for translation. So SBT, another problem with SBT, aside from its weird build file format that's neither really code or data, it's really old. It's actually more than 10 years old at this point. It's been around a long time. And in fact, it's written in a style of ancient style of Scala that if you want to understand deeply, you're going to have to talk to Odersky or John Pretty or someone who was around way back when that style of Scala was invented. It's very old. And old tools are hard to change because they build up a lot of users. And a lot of users mean that things have to slow down for backward compatibility reasons. And so you're seeing all these build tools crop up in frustration to sort of the fact that SBT has not been evolving very quickly. It's not been keeping up with the needs of users. It's slow, weird build file formats, not declarative. There's many things people want to do with SBT but can't do. And some of these new build tools are promising we're going to do source builds, we're going to have really super fast builds, or we're going to have totally declarative builds that are very, very easy to define. You don't have to know Scala to do it, just a few lines of YAML-like syntax. And what I'm seeing is I'm seeing library authors who are moving from SBT to other build systems. And I'm seeing the big companies who are moving, or in some cases already have moved away from SBT to one of the other bigger build systems that's more capable than SBT. So I don't know exactly what's going to happen here, but I do suspect that just like Ants was around for a really long time and was the standard build tool for Java, and of course was superseded to some extent by Maven, I think that what is happening in the Scala ecosystem is these pains, these sort of long-standing pains, are being translated into new tools, and ultimately, more likely than not, we're going to see one of these tools, maybe more than one, end up taking over a good chunk of the market from SBT. So Elixir. Metals. Has anyone used Metals? 10 of you. The rest of you IntelliJ IDEA, right? What? We've got Emacs and VI users here? I love Metals. Metals is amazing. I never took the time to learn Emacs or VI, and I love all the features in Metals. When you combine it with VS Code, it just provides such a pleasant code editing experience. It's amazing. It can do autocomplete, it can insert match statements, very simple support for symbol rename. Just incredible. This is not me typing, by the way. I'm way faster than that, just so you know. And it's one of these projects that was created by the Scala Center, which has produced a lot of great software over the years. Only, there's a little part of me that's concerned because Metals was not the first thing to come out of the Scala Center. Does anyone remember ScalaDex? Yeah, ScalaDex. Has anyone ever used ScalaDex? Even less people than Metals. And it's basically dead. They created this project out here that had a lot of potential, but they didn't have the funds necessary to keep on maintaining it. So ScalaDex is pretty much no more. Died before it got started, so to speak. How about Scala Bundler? Has anyone used Scala Bundler? Not a single person. Yeah, another really great project to come out of the Scala Center, but it wasn't maintained. Didn't have the budget to continue on. And Metals could be one of these projects that comes out of the gate strong, very, very promising, but ends up not being maintained. And what concerns me even more than Scala Center's history in this regard is the fact that two of the developers most instrumental to building the Metals experience have left the Scala Center. They've gone on to one of the big tech companies. And that's awesome for them. That's fantastic. I'm sure they're earning 5 times what they made at the Scala Center, or maybe 10 times. So that's awesome for them. But it doesn't bode well for the future of this tool. And my fear is that as much as I love Metals, I use it on a daily basis, it may end up more in the category of toy than production-worthy competitor to IntelliJ IDEA, especially now that the sort of brains behind this project have taken off for one of the big tech companies. And in order to really succeed in this space, I think it's actually necessary to take note of what JetBrains has done. JetBrains knows developer tooling. They really do. And one of the things that makes their tools so successful is that they embrace the corporate customer, the sort of 9 to 5. They're not building this for open source developers. They're not building it for hobbyists. They're building it for people who have to sit down at their computer for 8 hours a day and crank out code. They don't have any time to mess around. And one of the features that they need is the ability to customize it. Add a plugin for Spring, one for XML, or one for Play, one for this, one for that. And this customized experience that you get out of that is part of what makes IntelliJ IDEA so incredibly powerful. And in fact, the #1 feature request for Metals is dynamically loaded plugins. This feature request is more popular, as measured by little thumbs up signs, than all other feature requests combined. But it was closed, it won't fixed. And my fear, unfortunately, for Metals is that it's never going to be the production-worthy alternative to IntelliJ IDEA, which is a disappointment for me personally, because I love Metals. I absolutely love it. IntelliJ IDEA, I'm tired of the red squiggles on all my code. And I'm tired of all the slow autocomplete. I just want to get in there and get my stuff done, and IntelliJ IDEA is too slow for me. So build tools sprout up every few months or weeks. And test frameworks as well keep sprouting up. And every few weeks we've got a new test framework, it seems like. Even Scala is thinking about building a new test framework and including it in the standard library. These things are everywhere. In fact, never have I seen an ecosystem have so many testing frameworks produced in such a short amount of time. It's just amazing. For the size of the Scala community, it's astounding. And I think part of this comes back to the fact that the big frameworks, they're very powerful, but they're enormously complex. The last version of ScalaTest, for example, has 464 classes. That's mind-boggling. That's huge. Anyone remember the good old days of JUnit 1.0? Like we put the test assertion on our method and we wrote assert equals. That's it. That's it. That's how you write tests. Not anymore. Wow, we have our choice of BDD style or this style or that style or that style, these matchers and those matchers and this and that. And that complexity, it can be a little overwhelming. That's one of the reasons I think we're seeing pushback against the bigger, much more enterprise-grade testing frameworks. Another one is a lot of these testing libraries don't have first-class support for asynchronous. So you can do some things like it's very second class, like do timeouts work in async mode when you have futures? Or do they just work in synchronous mode? What's the story there? Most features don't have parity between async and sync. And then also, they are quite old. They're, in some cases, 10 years old. These are very mature testing libraries. And Scala, what it means to write Scala has changed radically over the past 10 years. We write a different kind of Scala these days than we did back then. And we take advantage of different language features. We do things in a different way. And we've learned a lot about what it looks like to do more idiomatic testing in Scala. And so, even though this is an example of a test written using ZeoTest, and you can see here it combines some really interesting features. It imagines everything as a value. So your specs are either tests or suites or compositions of those, which are ordinary values. And your test aspects, which are kind of like annotations, are just functions from one spec to another. And you can apply them either on tests or you can apply them on suites. And they allow you to specify you want a test to run JVM only, or you want it to run eventually, you want it to eventually succeed. If it's a little flaky, maybe you want to run a timeout, or you want to attach any of these different test aspects to the whole suite, you can do that. And then there's min test, and there's micro test. There's all these different testing libraries out here that are coming up with a new, more minimalist way of writing Scala tests. And it's my opinion that this is a symptom of over-complexity in the Scala ecosystem and a little bit of age. And that even though nothing's going to ever replace Scala test, it's going to be around way for longer than all of us, probably. It's going to be here forever. Nonetheless, I do think there's really interesting opportunity for new, much more minimalist sort of micro-testing libraries to come along and really change the way the average Scala developer gets started, especially for niche use cases like asynchronous testing or effect-based testing systems. The language. There's so much to say here. Let's talk about enums. So enums, a Scala 3 feature. And enums come along and they introduce totally new syntax to allow us to define what's called in functional programming a sum type. In this case, we can say that every color is either red, green, blue, or a mix. And this is an incredibly compact way to define the same thing with a sealed trait. Not only is it a more compact way to define the same thing as a sealed trait, but also it has tremendous benefits for type inference. Has anyone ever tried to create an option using the none constructor and end up getting back something that has none.type? And that's screwed with your fold left or your fold or some other type of operation. That's because sealed traits in Scala, they're not true sum types. When you construct a term of that sum, you don't get back the type of the sum, you get back the type of the term in the sum. And that leads to some horrible type inference problems. And also, you have to remember and you have to teach that if you want something like an enumeration in Scala, you have to use a sealed trait, and then by convention, you take all the subtypes of that and you put them in the companion object. A lot more complexity than necessary. Enums are coming along and totally changing this. This can be taught in a matter of 30 minutes probably to someone. And it's a lot more bulletproof. And finally, we can give developers the following guidance when we're training them. If you're modeling data, all you need are case classes and enums. That's it. That's 100% of data modeling. You don't need or want anything else. And this, you're going to have really good type inference thanks to the fact that enums provide a more true first-class representation of a sum type. So I think this is actually a simple, no-brainer, definitely going to change the game. Implicits. So first off, implicits are powerful. No doubt about it. And you need them in order to do some very advanced things in Scala. You can't get away from them. However, in application code, in userland code, How many times have you seen something ridiculous like an implicit int being passed around because no one wanted to pass it? Yeah, you know what I'm talking about. And even worse than an implicit int, implicit execution context. Why? Because there are actually more implicit execution contexts than implicit ints. There's more of them. Infinite number of execution contexts in theory. There's only a finite number of ints. If it's ridiculous to pass an int around implicitly, which it is, then I'm going to suggest, very humbly, that it's ridiculous to pass around an implicit execution context. And then we've got implicits being used for type classes and implicits being used for proof, compile time proofs. We've got implicits used for all these totally different purposes. They're too low level. They're too mechanical. They give you a language feature. It's not obvious to an average developer what to use implicits for. So even though we need them, and if you need an implicit, then you absolutely do need it. There's no other way around it. They're too low level a construct. And they're one of the most confusing things to a developer who's new to Scala. And they end up pushing some big companies away from Scala. And in my opinion, implicits are vastly overrated. And I'm very excited that Scala 3 is taking this opportunity to basically deprecate implicits in favor of some smaller, more use case driven features that we've seen implicits are useful for. Metaprogramming. So one of the amazing things in the Scala ecosystem has been macros. We have seen so many incredible libraries powered by macros. It's creating a massive migration pain for Scala 3 because all those macros are dead, like the white box macro is dead, black box macro is dead. It's all dead, it's all going away. But nonetheless, we've been able to build some amazing libraries that do incredible compile time computation, like a library that can parse JSON directly into your data structure using macros, and libraries that can generate huge amounts of boilerplate using macros. It's amazing. Unfortunately, all that's going away, but it is going to be replaced by something that's baked into the language and supported and way more principled than anything we've seen before. This is metaprogramming in Scala 3. We get a few different features. Inline, which gives us a way to do a limited form of compile time computation. We've got macros, which are not as powerful as the old ones, but they're very easy to use. Ordinarily, it takes a macro god to come in and make a new macro in a code base. But ordinary people like myself, who are not macro experts, have a shot at using the new Scala 3-based macros. And these are principled constructs. We can also do a form of staging. Staging is incredibly important for advanced use cases in Scala. You may not see this as a user very often, but this is going to enable a new type of library in Scala that is able to generate code at runtime in a type-safe way. It's going to open up whole new use cases that can't be done right now, not in the same fashion. And then we get erasure to sort of deal with some of the runtime overhead. My vote, metaprogramming, just like macros have enabled a huge amount of value in Scala 2.x, metaprogramming in Scala 3 is going to be amazing. And it's going to enable us to do things that, and because it's baked into the language and supported, we can grow on this, we can build on this, libraries can build on it, whole ecosystems can come out of our ability to do first-class supported metaprogramming in Scala 3. White space. No, Scala. Anyone seen this? Scala 3 white space sensitive syntax. Wow. What do you think about this? Your vote. How many people think it's an Elixir? 6? How many people think it's snake oil? Holy crap. Don't worry, I won't tell Odersky. Oh, yes, I will. I know who you were. I'm telling Odersky. This one's up to you to decide. I think, first off, the transition if there is going to be a transition to white space sensitive syntax, it's not going to buy us a lot of productivity, right? This wasn't a big pain that we had. But on the other hand, white space sensitive syntax is probably not going to impede adoption for new users. It's going to piss off lots of existing users, but it probably wouldn't impede adoption. Python, for example, has shown us that you can have a white space sensitive language and it doesn't significantly interfere with adoption. So the official vote is snake oil. Sorry, Martin. So in addition, we don't have time to cover all these, but there's some really amazing things in Scala 2.x as well as Scala 3. And they range from case classes, pattern matching, things we take for granted all the time that really do change our lives on a daily basis. Tail rack, custom extractors, local methods. Scala is very composable in that fashion. Modules, which are underrated and underutilized. Intersection types, we get union types in Scala 3, and way more things that make the Scala language the language we know and love. Libraries. Excuse me. Shapeless. The promise of shapeless is amazing, right? We can have type level lists and type level maps, all these different type level things, and we can combine them together. And we can operate on them. We can take and drop. We can do all these amazing things at compile time. It's a wonderful pitch. It is fantastic. See demos like this, and it's amazing. And then when people go to deploy shapeless, they get error messages that they can't figure out. Because in my opinion, every language has sort of a natural set point. This is the place where the language wants to be. And if you try to push it too far in any direction, the language pushes back on you and says, no, we don't really want to do that right now. And this is, in my opinion, Scala 2.x saying, maybe we're not quite ready for type level programming just yet. Maybe you should wait to Scala 3. And then we've got the compile time issue. I travel all around the world, and people tell me they ripped out shapeless and replaced it with Magnolia or something and ended up reducing build time from, dozens of minutes down to a fraction of that time, seconds. Shapeless has a reputation for really slowing down the build, and that's because, again, in my opinion, shapeless lies just outside the boundary of what Scala 2.x wants to be. On Scala 3, however, we've got some new features that could make this style of programming much more viable. But in my opinion, 2.x, unless you absolutely know you need shapeless, you're an advanced user, in which case, yeah, you're probably right, you do need it. If that doesn't apply to you, you're probably better off not using it. Caliban. How many people have heard of Caliban? Okay, I'm going to change that. You've all heard of Caliban now. So REST APIs dominate the web landscape, and REST APIs are used for one of two things. One is are used for services, and the other one they're used for data access. And the analog here with like programming in Scala, like functional programming in Scala, is that everything in functional programming is either data or it is operations on data. And in a similar fashion, we use APIs, REST APIs, to do two things. We use them to access data, or we use them to do things, like send emails and stuff, services and data. And the most common is actually data access, so bread and butter data APIs. We've all used REST APIs. REST APIs rose to success because what they were replacing was horrible. They were replacing SOAP and lots of other things that came before it, which were absolute disasters. And compared to those things, REST APIs are simple, but once you start using them, they're not so simple after all. Because we have to get data in general from multiple different API endpoints. And then we need to stitch them all together client-side to answer a given problem. And not only that, but what happens when we only want to retrieve a subset of data? Well, it seems like every different API has its own weird different extensions that allow us to pull back a subset of data. And then what happens when we want to search data? We want to find data that matches some criteria. Well, again, we're looking at different APIs having totally different conventions here. And what GraphQL has done is come along and said, look, all data is a graph. Instead of sort of flattening it out and sticking it in this weird REST API format and requiring you do all this work client-side, let's build a query language, very simple declarative query language, that lets you pull back the subset of the graph you're interested in, and just that, whether it's nested or flat. And in my opinion, this or something like GraphQL is going to totally end up replacing bread and butter data API, because it gives you everything you need and nothing you don't. It's like maybe they didn't need to build their own language here, but they did, and actually it works out pretty well. It's a good fit for semi-structured data. And libraries like Caliban come along and allow you to support GraphQL in a matter of a few lines of code. And Caliban in particular is powered by Magnolia, which allows it to do compile time derivation for all the boilerplate, which means you can write a few lines of Scala code and you can support a huge amount of GraphQL. And you don't have to do any boilerplate. It's all type safe. It is all checked at compile time. And it's all 100% async and sort of latest best practices standards compliant. I'm very, very optimistic about the future of Caliban, and not just Caliban, but other GraphQL libraries like Sangria in the Scala ecosystem. I think they hold tremendous potential for just cutting out the crap of building REST APIs. Actors. So actors basically come from Erlang. And the promise and hype of actors was, this is how you do concurrency, right? Build systems that have millions, tens of millions of interacting actors, and when one part of it fails, it just comes back online auto-magically, solves all your problems. And honestly, actors worked great for telco. They work great for switching systems. That's what they were built for, and they work great there. But then they came to Scala, and everyone started using them in all kinds of different places where they didn't really belong. And I've talked to so many people who are stuck with a code base built using actors. No one really knows why they chose to use actors. It's not distributed or anything. It's just local machine. In some cases, they're not even using it for concurrency. They have these code bases that no one understands and no one wants to change, and they're almost impossible to test. Actors are not the solution to all problems. One of the problems with actors is that an actor-based system forms a graph. You have different nodes exchanging messages with each other. And you cannot understand a graph by understanding its pieces, because the graph is totally connected. So to understand a graph, you need to understand and keep in your head the entire system. And of course, it's very difficult for us to do that, which means it's extremely difficult to understand the correctness or even behavior of an actor-based system. Lots of messages are being sent lots of different ways, but it's very hard to piece that into an accurate mental model inside your head. And not just that, but actors don't really solve the hard problems of concurrency or distributed programming. They don't solve the problem of making changes to state in a consistent, isolated, and atomic fashion. And they don't really solve the problem of deadlocks. You can actually deadlock an actor-based system. All problems that you have in traditional concurrency, you can create their analog in actor-based systems. Actors basically deal with the problems of concurrency and distributed programming by not dealing with them and saying, no, we're going to make it really hard for you to even try to do such a thing. And that makes the actor-based solutions to things very complex, very big, very monolithic, and ends up pushing the complexity into userland code where it's more likely than not to be incorrect in some percentage of cases that hopefully no one notices. So while it's certainly useful, I'm not denying that actors have their place. I'm going to say they're overhyped, and they're deployed in too many cases. Zio. So I am not going to comment on this one for obvious reasons, due to conflict of interest. So I contribute to Zio. I started the project. And I won't deny there's a little bit of hype around Zio. And it's being deployed at some very big companies in some very interesting cases. So I'm very excited about that. But I'm going to let you vote on this. How many people think it's a snake oil? Come on, get your hands up. It's okay. Yeah, it's okay. It's okay. Awesome. More people. How many people think it's an elixir? Okay. My paid chills right here. I paid all of those people to say that. It's coming. Yeah, so I personally don't know. I'm very excited about the future of Zio. I think it could end up being a next generation fabric for building modern concurrent async and distributed applications. And hopefully we can be very careful in how we talk about Zio so as not to overinflate expectations. That's always a danger with new technologies. I've even seen people go out and take Zio and take a function that returns an either and turn that into a function that returns a Zio effect. No, please don't do those kinds of things. Know when to use a technology and know when not to use it. And there's plenty of cases where you should not be using Zio. And in addition to the libraries we talked about here, there's just so many great libraries out there in the Scala ecosystem. I've collected some of the maybe lesser known libraries that I think are really interesting and worth taking a look at. So by all means, check some of these out. You're gonna love some of them. All right, now for the section you've all been waiting for. I have to go really fast because I'm approaching the end of my time, and they're going to come up here and take me off the stage, drag me kicking and screaming. So you can go to even someone who works for Lightbend, and you can be like, hey, you know, I think actors are maybe deployed in too many cases. And they'll be like, yeah, you know, you're right. Yeah, I've seen that. You know, people putting actors where they don't belong. If you go to functional programmer, however, and say, maybe a 10-layer monad transformer stack on top of higher-kinded parametrically polymorphic type is not the best idea to introduce on my unwitting coworkers, then they will hunt you down, they will find you, and they will get you. So I have to be super careful in this part of the talk. Actually, I think I've already been excommunicated from the functional programming community, so screw that. I'm not going to be careful. Tagless final. Tagless final. The hope and promise of tagless final is to allow us to reason polymorphically about our effect types, to allow us to constrain effects to the smallest subset of capabilities we need. And of course, to allow us to provide a layer of indirection so we can switch different effect types. You know, if we ever wanted to switch away from Zio to Monix or Cat's IO, which you would never want to do, of course. The reality is, however, the tagless final as practiced by the Scala community involves creating a bunch of lawless type classes. These are interfaces that have been called type classes. They're not actually type classes, with methods that have no laws, just signatures and names, and stuffing those up into parametrically polymorphic functions. This has nothing to do with algebraic reasoning. There's no benefit of algebraic reasoning across tagless final as practiced by the Scala community. Now, there is a benefit, and that benefit is, when you look at a tagless final codebase, you look at a method here called fancy method, assuming that your programmers have been super diligent in their code reviews and not allowed any side-affecting code to go into the body of fancy method or any of its many dependencies, assuming that is true, then you can look at this fancy method and you can tell that it calls methods in not a type class, still not a type class, and never a type class. You can tell that, and that's benefit. That's a benefit because now I don't need to dig into the implementation of this method in order to see what methods it calls. However, there's a way to get the exact same benefit without tagless final. Write a tool that goes down the call graph, right? And pulls out all the side-effecting methods and stuffs them in a comment. That there is the sum total benefit of tagless final, as practiced in Scala, aside from the indirection benefits, which are of questionable usage. Yes, they're literally going to get me in the next few minutes, so I'm going to go fast. So in my opinion, tagless final, if you like it, if you're using it, then by all means, keep using it. Many people find this style to be useful to their productivity. On the other hand, if you are looking at this wondering, what the heck is the FP community smoking? You're not the only one. The onion architecture is an alternative approach that says, instead of just embracing effects everywhere in our application and using tagless final and monads everywhere, let's instead try to pull the effects out of our business logic. Let's try to make it so that we have a core part that is not described by IO monads or any of that. Just make our business logic as pure as possible, as simple and pure as possible. And this has profound benefits on testability and reasonability. And if we're able to make little domain-specific languages, data structures or other ways to pull those effects out, we can reason about them and we can maintain our software in a much more declarative fashion. And then later at outer stages of our application, we can translate those to middleware, translate that middleware to infrastructure and so forth. I'm very excited about onion architecture. I think it's one of the most underutilized techniques in the Scala programming language. Type classes. So type classes allow us to describe commonalities across different data types. They allow us to see common structure across a range of different data types. And we describe that common structure with laws, abstract algebraic laws that are true for all instances of given type. This is the secret. Type classes are the secret to writing generic code. They're enormously powerful. But, I thought I had another slide there. But the problem with type classes is they don't have a native encoding in Scala 2.x. And even though it is true they are the key to generic programming, most of you will never create your own type class. And type class-based parametrically polymorphic logic in your application is going to be 1%. 1%. You're going to have 99% stuff that's not type class-based, 1% that is. So even though they do have value, they do have cost, and they're only going to make up a small percentage of your application. Most business applications don't need more than semigroup, monoid, and basically traverse. And even the traverse they use is limited to a few different use cases. For library authors, on the other hand, they're much more useful. Finally, Scala 3. Let's go through this really fast. Scala 3 gives functional programming community some new tools to play with. And it is absolutely true. We're going to use these new tools in ways we should never. In ways Odersky would never recommend, in ways I wouldn't even recommend in some cases. Oleg, yes, you're going to use this stuff, right? In ways that you probably should not. So, ADTs, though, first-class support for type classes using a extremely compact syntax that deletes all the boilerplate out of Scala 2.x. This is going to make type classes more accessible than ever to beginners. Derivation of type class instances. Automatic derivation that's pluggable, programmable. We can add our own derivations for our own type classes. And finally, a whole new range of fancy type features, including type lambdas and intersection types and union types and even match types. We are going to build some amazing stuff amazing and scary, very scary stuff with this, trust me. Overall, I think Scala 3 is the most exciting thing that is happening to functional programming in Scala, and I'm super excited about its future. So there you have it. My thoughts on the Scala ecosystem, languages, libraries, and tooling. And I wish I had more time, but I don't. I've run out of time entirely. Don't even have time for questions, so you'll find me out in the hall. Thank you all for coming to this talk this morning. I really appreciate being here and being provided the opportunity to share these controversial opinions with you today. Thank you.
Thank you very much, John. So with all of these technical issues, we unfortunately forgot to introduce you. So please, once again, give a very well-deserved round of applause for the one and only John DeGos. Thank you very much. So I guess there is a little present for you, just to remind you the last talk of 2019.
Thank you.